EU institutions, it will be of great help. That's why we're here today. Jean-Pierre Ypersele.
Climatologie, de sciences de l'environnement. Vous avez occupé des
You played a major role in the IPCC when, together with Al Gore, received the Nobel Peace Prize for its work on climate change. You're a climatologist and a professor. It's more than time to wake up, as you've explained in the media in recent weeks. And I'd like you to elaborate on that now.
Merci, Monsieur le Président. Ici.
Thank you. But with your permission, I'll speak English because my slides are in English, so it'll be easier to speak, though I know you have interpretation.
First, a quick reminder. We are in a very specific situation. We are just at the right distance of the sun. We're not too close, like Venus is, plus 500 degrees Celsius. We're not too far, like Saturn, minus 200 degrees C. We have a wonderful atmosphere, but that atmosphere is very thin, as you can see on this beautiful picture taken by the International Space Station. And we're using this atmosphere as a dustbin. Isn't that a shame? We are using it as a free dustbin on top of that, which is part of the problem, for our greenhouse gases. And by doing that, we're actually thickening the layer of thermal insulation around the planet. And this is what is causing the warming under that thermal insulation layer. Actually, this comparison, which will be held by this animation, which is a bit hard to see with so much slides, sorry about that, but you'll have all my slides available afterwards. I'll give you a website address afterwards. By looking at the CO2 problem as in the way of an increasing thickness of an insulation layer, which is shown here on the left by that evolution since 1850 of the CO2 concentration from 280 parts per million to more than 400 today. And then on the right diagram, you have the evolution of temperature, and you see how they are both correlated. We have gained plus 1 degree Celsius globally already. So by making this comparison with the thickening thermal insulation layer, one can understand, without any complicated climate model, without any equation, why it is so important to reduce emissions to zero as quickly as possible. Net zero if you want the details, but practically it means zero. Zero emissions from fossil fuel, zero emissions from deforestation, and as long as we have not reached that level, that insulation layer around the planet, remember we are under that insulation layer, will continue to thicken, and the warming, as this diagram shows, will continue as well. Another way to look at the very fast increase in that CO2 concentration is to look at the last 10,000 years, shown here. You see that for 9,800 years, the concentration was very stable, around 270, 280 parts per million, and then an explosion since we started to burn massively coal, oil, and gas over the last 200 years. Look, the number for May this year, 415 parts per million. This is the number just a year before, 412. So at the moment, we are increasing that concentration by approximately 3 ppm, 3 parts per million every year. So we are not yet on the way of stabilizing that concentration. This, of course, has many other consequences than just an increase in the average temperature. It's an increase, for example, in the frequency or intensity of very hot periods, like the periods we had this summer, which actually killed thousands of people in Europe. That's probably not known enough. I'm taking the liberty to say thousands of people because I know the statistics have just been published for Belgium. It's 716 Belgians who died this summer during the 3 relatively short hot day periods. So if that's just for Belgium, for 11 million people country, it's probably thousands at the European level. But it's also an increase in heavy precipitation events, which of course leads very often to floods and other disasters. A very important longer-term consequence of the warming is that probably at the time we're speaking, the average global temperature is probably on its way to exceed what I call the conservation temperature of the big ice sheets in Greenland and Antarctica. And those ice sheets contain together the equivalent of 75 meters in sea level rise globally, 75 meters if they melted completely. And right now already, this is the volume of water. If you know New York, if you know the size of Central Park, you know it's a very big park. If you know the height of the tallest ice scraper in New York, this is the height of that volume of water. It's 1 billion cubic meter of water that are added every day and a half right now, just from the Antarctic ice sheet, which has started to melt. Every day and a half, 1 billion cubic meter. And this is one of the factors contributing to sea level rise, and it's actually accelerating, as the recently released IPCC report on sea level and the cryosphere indicated. If we look at the future, if we stay on the business as usual scenario on which we are still right now, the red curve at the top, we would reach 4, 5, even 6 degrees above the pre-industrial by the end of the century. And that could have huge consequences in terms of the inhabitability of the planet. Also, these are average numbers. If you look at the space distribution, look at what it means for Europe. Northern part of Europe could have, on an annual average basis, more than 10 degrees in parts of the area. It's also changes in the precipitation patterns, with some regions receiving more water, but some regions, for example, the southern part of Europe, the northern part of Africa, receiving significantly less water, what's in yellow or red on this diagram. You might think a few degrees, could this have such large consequences in the planet? Well, let's look a little bit in the past. This is how the planet looked just 20,000 years ago, at the peak of the last glacial maximum. By the way, that glacial maximum occurred for purely natural reasons, astronomical reasons, which are well understood and which have nothing to do with the factors active today on the climate at the century time scale. Look, we have an ice sheet over North America and over Europe that is 2 to 3 kilometers thick. There's so much ice there at that time that the sea level is 120 meters, not 120 centimeters, 120 meters lower than today, okay? Why do I show this? Because the difference in temperature globally between that climate and the climate we are presently heading to is only 4 to 5 degrees. Okay? So 4 to 5 degrees, when one speaks about the global average, represent huge changes in the inhabitability of the planet and even the geography, because as you can imagine, the coastlines are changing. Now, the good news is that we only have 75 meters in the remaining ice sheets. We couldn't have another 120 meters. And the other good news is that it takes millennia to melt such large quantities of ice. But still, in the long term, we are headed to significantly higher levels. Even by the end of this century, plus 1 meter or even more is quite possible with the present trajectory, which would have huge consequences for many people, millions of people in the world. And you don't need to go very far, just go to the Nile Delta. The red area here is just 1 meter above the level of the Mediterranean, and 20 years ago when this diagram was plotted, it was an area where 10 million Egyptians were living, so you can imagine the consequences. This report has been mentioned mentioned already by Rebecca Thyssen, and it's a very important report because it's highlighted the significant increase in the severity and of the risk level for a warming of 1.5 degrees C going to 2 degree warming. The impacts and the risk are significantly higher for 2 degrees than for 1.5 degree. One enters the red zone for many of those criteria, which I don't have the time to explain in detail here. Just for 1.5 degree warming above the pre-industrial, we have gained +1 already, remember. So this explains why, as quickly as possible, and if you have understood my comparison with that insulation layer, you understand why, we need to follow a trajectory at the world level, which looks like the trajectory shown here, which reaches the net zero value for global CO2 emissions by the middle of this century, that is in less than 30 years from now. And clearly, the present national plans, including the plan of the European Union that is on the table since the Paris Agreement, is far from being sufficient to be even on a 2-degree trajectory, while the Paris Agreement, remember, doesn't speak about a 2-degree target anymore. That was Copenhagen 10 years ago. It now speaks about trying to stay well below 2 degrees while pursuing efforts not to go above 1.5. And if one looks at the aggregation, the total effect of all the national plans available up to now, if they are not very quickly updated, we would be, it's probably hard to see, but a little lower. I don't know if you see my moving arrow there, a little lower than the business as usual trajectory, but still very far from the green curve showing the 1.5 trajectory or the blue curve showing the 2-degree trajectory. Numbers have been quoted earlier, but this number is important as well. We are spending right now in the EU €1 billion per day just to buy fossil fuel outside the border of the EU. So this doesn't even count the money to buy Polish coal, for example. And very important elements we have to remember as well is that every year the burning of fossil fuel and of wood, so that is deforestation, kills 7 million people per year, including 500,000 per year. So that means, and it's just an example of the many synergies that could be obtained by fighting climate in a clever way. And climate is objective number 13 here in the SDGs, but there are many of the other goals, sustainable development goals, could actually be helped by proper climate policy. So right now, humanity has the choice. Either we stay on the present trajectory, and by the end of the century, we have a much warmer world, particularly over the continents, a world where adaptation would be quite difficult, both for humans and for ecosystems, or we fight climate change with a lot of determination, and we go towards a warmer world, but a world where adaptation would be significantly more possible. I sincerely hope, and I'd like to thank as well, like a previous speaker, the movement of the youth, and it's not only Greta, it's all the others as well, but they've been inspired by Greta, and this is moving the lines now, and I wrote a letter in Le Monde, published in English and available on my webpage if you wish, and this is the same webpage, the first one, where the slides I've just shown to you will be available whenever I have time. So it won't be tomorrow, I'm too busy tomorrow, it will be no later than Friday. Thank you for your attention.